Okay, so we started with these 4 practice problems, and you're going to learn about the law of sines later today. Did we need the law of sines for any of these? No, because these are right triangles, and right triangles are pretty easy to do with trig. All right, this one, if there was one most important one, it was probably number 1, because you can do it 2 different ways. One way to do it, you could have said tangent of 30. Why wouldn't I use sine? Sine has hypotenuse in it, Anna. We don't even have the hypotenuse. And it's not even marked with a variable, so why would we want to use that? So I use tangent of 30, which is opposite over adjacent, which is 2 over x. Then I'd multiply both sides by x, and that would cancel. And then I'd say x equals 2 over tan 30. Raise your hand if you had that one right. Okay, but the problem is you can't leave tan 30 in your answer. Did you know that? Okay, why can't you leave tangent of 30 in your answer? Because you know what tangent of 30 is. Would everybody please make the 30, 60, 90 triangle and label it with the key numbers I told you to memorize yesterday. There's a 1 involved, there's a 2 involved. And I say it's almost as easy as 1, 2, 3. Charlie, what do you think the shortest side should be called? Did you just say 1? You were correct if you did. Max, what do you think the largest side should be called? 2. And the last one? Everybody? All right, good. So if I asked you for sine of 30, you'd go 1/2. Do you see it? Do you see how sine of 30 is opposite of hypotenuse? 1/2. Boom. Okay, so what we were doing there was tangent of 30, and you're not supposed to just leave it as tangent of 30. You're supposed to go, I know tangent of 30. That's easy because I can make this triangle. And tangent of 30 is TOA, opposite over adjacent, 1 over root 3. Now I did say there was that rationalizing thing, but you don't have to do that. You just have to know that it could be done. All right, so tangent of 30 is 1 over root 3. Now, in this case, it's going to work out really nice because when you divide by 1/3, it's like you timesed by root 3. So then the answer is 2 root 3. Okay, now that took a long time to get to. Now again, that was divided by 1 over root 3 means multiply by root 3 because you flip and multiply. You can put it over 1 if you want. Okay, but there was another way to do it that I taught you yesterday and I think is actually superior. Let me show you how a kid who, do you get we had to draw the 30, 60, 90 triangle anyway to get the final answer? So then what, in my opinion, the best way to do this kind is you draw the 30, 60, 90 in the same orientation, you know, with the pointy end on the right, and you make this the 30. I don't have to label them all. I'm going to go 1, 2, square root of 3, and then you start with the variable, and you say x is to root 3 as 2 is to 1. And do you get how fast that was? And I'm just going to times by root 3 now to clear the fraction. And x is 2 root 3. Boom. I think that was faster. Notice I didn't even use the word sine, cosine, or tangent when I did it. I just set up similar triangles using the classic 30, 60, 90. What was the other big triangle I told you about yesterday? 45, 45. Everybody make that one quick and label its sides. Sam? What are those sides? Remember them?
Not really.
Okay. Have you got the triangle drawn yet? As soon as you do, we'll label it. Naomi, what do you think the sides are on that? 1, 1, square root 2. Yes. And do you remember the fast way to find the third side of any right triangle? You go square root of, and then you take the other two things squared, which in the case of ones, 1 squared is 1, 1 squared is 1, and if you're on the longest side, you add them. Look, root 2. So that's a way if you ever forget, I don't remember the third side. I can't remember if it's square root of 2 or square root of 3. That's a common mistake. You can just take a second and do that. So let's see if you processed what I just said there. If this is 3 and this is 4, well, I know this side's 5. That's a little too easy. So then I'm going to make this, if that's 3 and that's 6, everybody do the quick square root, boom, boom, I know the answer way. I don't want you to spend forever doing a squared plus b squared equals c squared. Huxton, do you get this way?
It's square root of 45.
Just tell me how you got it though.
Oh, I added the 6 squared.
Which is
plus-
36. Always start with a bigger number because on the ones on the sides, you always wanted either taking the bigger number minus the other number. So always start with the bigger number. Good. Keep going.
And then I wrote 9
And then you wrote 9, and then you knew it was plus y.
because I'm solving for the
It's the biggest side. Good. So square root of, and then that's going to be 45, square root of 45. Now, let's think about square root of 45. On a test, would you be able to leave it that way? No. You would lose some, like, maybe it's only 5%, but hey, who wants to go from a 95 to a 90? Nobody's, like, psyched about that. So everybody take a second and make this 2 square roots and simplify it down. Lucas, what times what makes 45?
What times what is 45? 5 and 8, but that doesn't.
How about 9
That's
and
nine,
5?
yeah,
How
nine.
about that? And then square root of 9?
3, so 3 squared root of 5.
3 square root 5. The fast way to say it is just 3 root 5. Make sense to you guys? Okay, so what else did I tell you yesterday? Well, one of these simple things is these angles always have to add up to 180, right? Don't forget that. And if I tell you that this side is bigger on the bottom, then you automatically know. If I tell you it's a 30, 60, 90, you can tell which one's 30 because it's across from the smallest side. Do you agree the blue side is the smallest side? Then that has to be 30. I mean, if it's a 30, 60, 90. Okay. And if it's one of those, then you oftentimes put a mark like that, and it just means those sides are equal. Which means it's 1, 1, and root 2. All right. So let's just one last problem like that to make sure you get this. What if I say this is root 17, and I'm saying it's a 30, 60, 90? You should be able to tell which one's 30 because it's across on the smaller side. I want you to do it the similar triangle way where you draw a little helper triangle next to it and set up a proportion. And I want you to solve for Q. Pausing for a second. All right. Did you realize that this was the 30 because it was across from the shortest side over here? All right. And therefore, this is 30, and therefore, this is 1. I always start with that. If you put the 1 in the right spot, you'll probably be okay. I mean, you still could mess up. This is 2 because it's the longest side. People get confused. They see a 3 and they think it's bigger than 2, but the square root of 3 is not bigger than 2. All right. So now, I hope you can tell me how to set up the proportion. Ashana, can you do this? Oh, you started with Q. Very smart. Q goes with square root of 3 like. Perfect. And then don't cross multiply. The middle school teachers may have ingrained that into your head so strongly you're tempted to. Instead, multiply by root 3 on both sides. Why? Because this one step and I'm done. Boom. Q is root 17, root 3 all over 2. Yes, it'd be better if you multiplied those out. Because root 17 and root 3 can make root 30, 21, root 51. Root 51 over 2 is better. I don't think I would mark that wrong on the test, but that's better. Okay, any questions? All right, then what are we doing? What is this new thing? It's not this. We already know these. Okay, it's not this because we've already practiced that. Just you know, like we know it's a 3, 4, 5, right? Boom, because we already have it memorized. Let's just talk about a couple other Pythagorean triples like that I want you to memorize and just like have them all the time. 5, 12, what's the other one? 13. Any multiple of these, like times all of these by 2. 6, 8, 10. See what I mean? But we don't want to write down 6, 8, 10 because then we'd have to multiply them all by 3 and say 9, 12, 15. I mean, I think you get that we can multiply these by anything we want. There is one more Pythagorean triple that's worth memorizing. Does anybody have it in their head? I just want to see who's got it. Only Samuel. All right. Hit us. What is it? Hold on. I'm not even sure you're right. Maybe you are. 8, 15, 17. Now, let's check him. He's probably right, but how do we check it? A squared plus B squared equals C squared, right? So this is 64, and this is 225. Somebody help me with 17 squared. What?
289.
Does this and this really add up to 289? All right, looks like it does. Now, the reason that I guess I don't know why I haven't got that one in my memory banks. I'm writing it down, like you should be right now. Because that's a good one. Because the numbers are all small enough. There's one more that starts with a 7. Of course you know it. Anybody else got one that starts with a 7? All right, so we got the 3, 4, 5. I got the 5, 12, 13. Just pro tip, teachers usually use those two the most. Okay, 5, 12, 13 comes up a lot. Because the numbers are still fairly small. These kind of got big. And it's got an 8 to start with. See, I memorized it up to the one that starts with a 7. Want to tell me that one?
724.
Yep, 7, 24, 25. The three sides of a right triangle. Yeah, okay? And then the one you just gave me, I got to memorize this now. Dang it. 8, 15, 17. I'm writing it down. It's good to know those. You know why they use them a ton? Because they come out to nice whole numbers. All right. Nobody memorizes the 3. That should be small. The 2, 3, and square root of 9 plus 4. Square root of 13. Nobody memorizes that, right? Because they aren't whole numbers. Okay, but now let's go from a 2, 3, 4 triangle. No, there's no such thing. There's a 3, 4, 5 though. But we're going to make it 3, 5, and some other number that doesn't make a right triangle. Okay, so could I make two sides that are 3 and 5 and then connect them with something that was 6? Could I? I couldn't make a right triangle, but could I make a 3, 5, 6 triangle? So that's the first thing you got to contemplate. Not every combo is possible. Like, think this through. Could I make a 3, 5, 12 triangle? Just look at them. Think about it. Could I make a 3, 5, 12 triangle? This messes with a lot of people's heads. There is no way to make that triangle. Know why? Let's say this is 3, and let's say this is 5. They're not going to possibly make, like, their sides can't work to make a right triangle with. Okay, they wouldn't connect. If I gave you a piece that was 3, I gave you a piece that was actually 5, and then I gave you a piece that was 12, it would look like that. Like, you can't take those 3 pieces and make them into a right triangle. You know what I mean? And use them all as sides. All right, so basically this was too long, right? Well then, there is a zone where you can make a triangle, but it's not a right triangle. Let's process this. Could I have a side that was even 8 long? Would it even make a shape anymore? If I had one that was 8 units long, one that was 5 units long, and one that was 3 units long, could those 3 be put together to make a triangle? No, they couldn't. All right. So what does that tell you? This is 3, and this is 5, and this is 8. Well, you got a call. You can turn your volume off. All right. So the 3 and the 5, if you add them together, that's going to be right on the edge of where it would make a possible triangle, but it needs to be bigger than the 2 smaller sides. Nope, sorry, smaller than the 2 smaller sides added together. So should I be able to make a 3, 5, 7 triangle? Should it be possible to make a 3, 5, 7 triangle? Will a squared plus b squared equal c squared? No, it won't. Okay, because it's not a right triangle. But if I put those together, do you get that 8 was the number where they couldn't make a triangle anymore? But 7 could make a triangle, and 6 could make a triangle. Could I make a 3, 5, 5 triangle? This is 3, and this is 5, and this is 5. Could that work? A 3 and a 5 and a 5? Could I make a 3, 5, 5 triangle? Yeah, I could. All right. So you want the third side, the two small sides, carry the key, your two small sides, if you add them together and use that, that won't work. But it has to be smaller than that. Okay. So let's just go with the 3, 5, 7 triangle. We have talked it through enough that you know it exists. Now, is that a right triangle? No, that's the whole point. Because a squared plus b squared won't be c squared. But I'm going to use this moment to introduce two big things. Yes, today is officially about the law of sines, but we're going to learn this other one first because I think it fits better right now. Yes? If you have to go, you have to go. Okay. All right, so I'm going to go with a squared plus b squared, but wait, I leave a gap equals c squared. Well, we didn't tell you when we first told you about this. You would probably learned about this in 7th grade. A squared plus b squared equals c squared. My guess it was 7th grade. Maybe it was 6th for some of you. But what we never told you is that technically we could have added one more thing to the formula and it would have worked for any triangle, not just right triangles. A squared plus b squared, memorize this, minus 2ab cosine of c equals c squared. Now, c is an angle. C is the angle that's across from little c, the side. So I'm just going to introduce this one because I kept talking about a squared plus b squared doesn't equal c squared. It would if you included this. And this is not called the law of sines. I'd like you to take a wild guess what it's called. Yes? Law of cosines. Because it's got a cosine in it. Okay? Do you get how it's pretty much a squared plus b squared equals c squared with one little modification? All right. So this would be true for every triangle, whether it's a right triangle or whether it's a not right triangle like this one. Okay, so, but the one that we really are focusing on for today is the one called the law of sines. And that is, surprisingly enough, based on sine. Now, I'm gonna take the same shape and I'm gonna take off the sides on it. And I'm just gonna say, you guys agree this is not a right triangle, right? Okay. And now, usually, the sucky part of this is that doesn't always work. Usually the longest side is called C. And the A and the B can be reversed. Okay, that, in the right triangle, that was like a law. The C was always the biggest one, and the A and the B could be reversed. But here, it kind of can be any way the teacher wants to make it, okay? But I'm going to personally use A and B and C like this. But just so you know, when they're not right triangles, C doesn't have to be the biggest side. But we usually do that, okay? All right. Now, if I call those little a, little b, and little c, they're supposed to be lowercase letters. Then do you get the logic behind why I'm going to call that big A? I'm going to call this big C, and I'm going to call this big B. Do you get that? There's usually somebody who still doesn't quite get it. The lowercase and the capital kind of go together. Make sense? Little b, big B. Big C, little c. Okay? Now, given those are A, B, and C, then there is an angle associated with this spot right here, right? We would call that angle A. We would call this angle C, and we would call this angle B. Does that make sense to you? We use the capital letters for the angles. So this spot right here, this is angle big A. This is angle big C and angle big B. And I could be saying the word capital B too. Wouldn't matter. Okay? All right. Why all that setup with the A's and the B's and the C's, Mr. Server? Because, do you get there's A's, B's, and C's here? And this C is not exactly the same as this C, because one of them's a little c and one of them's a big C. The big C is the angle. Okay, so the capitals, those are the angles. All right. So last but not least, I got to introduce to you the law of sines. You ready? Surprisingly enough, it starts with sine. Sine, and I want you to tell me, am I about to put a capital letter or a lowercase letter? Capital. And you can pick any one you want. So alphabetically, let's just pick A. Big A over little a. And I say big and little just because lowercase and uppercase are a bit of a pain in the butt to say. So equals, and I bet you somebody's going to figure this out. It's not incredibly hard. Yes?
Sine of B over sine of B.
Yep. But you got to say them different.
Big B.
Big B over little b. And, wait, no, not plus.
Equals.
It's another equals. It's one of the few formulas you'll ever see that has two equal signs in it. And then, I bet you know the last part.
Sine big C
Yep.
over sine little c. Or sorry, over little c.
Yep. That is the law of sines. Okay, do you get that if you have a home improvement project, you go grab your tools. Do you use the saw for everything? No, certain times the saw is good, certain times the drill is good, certain times the hammer is good. Okay, well, do you use this for everything? No. Sometimes you use this. Different tool, different job. So what's this good for? And you might want to write this down. When you have an angle, see, weirdly, on this formula, you don't even have to have any angles. You might be like, but what about the C? Well, then you're solving for an angle. You'd have A, B, and little c, and then you could solve for big C. So you don't even need an angle for law of cosines. So when you have an angle, you have to have an angle or you're not going to use law of sines. The end. Okay. But if you have an angle and the side across, that's when you want to use this thing. When you have an angle and the side across from it. So for example, does this, did I draw it weird enough that you can tell that is not a right triangle? Okay, and I have an angle. Would you possibly believe that's a 20-degree angle? Does that seem possible? Okay. And now let's say we've got the side across from it, which is, let's say, I don't know, does that seem like it could be like 3 maybe? Sure, scale, I mean, I haven't said scale yet, so. All right, now, one more rule about these things. You can never solve them unless you have 3 of the pieces of the puzzle. Let's zoom in on this for a second. Do you get if I knew this and I knew this, I still wouldn't be able to solve for big B or little b. I mean, I have to have one more piece of info. If I knew an angle on the side across from it, then I got, this is all ready to go, but I need one more piece of info. Do you get I could give you little b, and then you could solve for big B? Or I could give you big B, and then you could solve for little b. All right. So I need 3 pieces of info. You know why? Because in the end, it's kind of like this. You got 4 things you're going to be in a proportion for the law of sines. If you give me 3 of them, I can find the 4th one. But if you only give me 2 of them, how am I supposed to solve that? I can't solve that. All right, so you need 3 of the 4 pieces. So have I given you enough to solve this problem? No. But could I have enough if you told me one more thing? Yeah, I could either tell you an angle, if I told you this angle right here, or I could have enough if you told me this angle, because if you tell me either one of the angles, I know all 3 angles instantly because they add up to 180, right? Or I could tell you a side. I could tell you that side, or I could tell you this side. If you tell me just one more thing, I can use the law of sines on this. All right. I think the easiest kind, and therefore the one we should start on, is if I give you an angle. Would you agree this angle right here is way less, and I know it's messed up because this isn't the straight side, but let me make it more straight. Would you agree that that angle is way less than 90? Okay. Could you believe that it is 60? Does that seem possible? Okay. Let's say it's 60. Then we have enough info. We got 3 pieces of info, and that's enough. Because actually that almost instantly gives me the 4th piece of info. But wait, it's really important. If I'm about to use a formula that's got A's, B's, and C's in it, do you get I need to pick which side's going to be A and B and C? Do you get that I get to pick? All right, my advice to you, because of how the law of cosines work, is get used to making the angle and the side across from it, call those C. Do you get this? That makes this big C. And that makes this little c. And the A and the B, they never matter. Just like in right triangles, the A and B, we could pick either one to be either one. We don't care. The C is the one that matters. And the A and B can be flipped and it won't matter. All right. Now, there were some hands along the way, but I was in a mode where I didn't want to stop because I was afraid you'd get lost if I stopped. So at this point, I've seen a couple hands that popped up and then went away. Any questions? Okay. Then I've got big C, little c. Now I'm going to pick this to be big A. It wouldn't have really mattered, but now I'm going to pick, that has to be little a then, because it has to be across from that angle. And I'm going to call this one big B, and this one little c. So, no, little b. Yikes. Now I can finally actually use the law of sines. So let's do it. If I were you, I would start with the 2 that we know. So I'm going to not write out the whole law. I think you know it. It's simple enough. So I'm going to go sine of 20. We only have one angle, so let's use sine of that. Oh, wait, we have 2 angles. My bad. Sine of 20 over 3. Get what's happening here? This one, going with this one, equals, and then what? Well, it's almost unlimited. Do you want to solve for little a? Do you want to solve for little b? Do you want to solve for big A? We already could get that. It's just because they add up to 180. Do you want to solve for little a? So it really depends on what they ask for. But as long as you start with this and you put in one more piece of info either on the top or the bottom, we'll get it. All right, so let's just do it for A. Let's try to find little a. Well, then I'm going to have to do sine of big A, but I don't know big A, but you do, over little a. And can't you just use logic to find big A? Think about it. This angle right here. You know that angle. What's that angle? 100, because that adds up to 180, so that must be 100. So then this is sine of 100. Now, nobody goes around memorizing the sine of 100. And nobody memorizes the sine of 20. If these had been 30s and 60s, do you get we would expect you to do it? You can't just leave sine of 30 in your problem. You got to be able to go make the little triangle and go, oh, that's 1/2. If you were going to only memorize 1, that's the one I memorized. Sine of 30 is 1/2. It comes up zillions of times. Okay. So here we are with this. And now, I am regretting something. Do you get that it might have been smarter for me to start with the variable on top, because now solving this is going to be a bit of a pain? If I had put the variable on top, I would only have to multiply by one thing to clear the denominator and the a to be alone. See what I'm saying? Do you get you're allowed to? I never said it, but let's look back at this law of signs thing that we wrote down. And where is it? It's right. Oh, I erased it. Sine of big A over little a. Sine of big B over little b. Sine of big C over little c. Do you get that would just as easily be flipped? Little a over sine of big A. Little b over sine of big B. And little c over sine of big C. You are allowed to use that in either way you want. Like if you feel like it would probably be better to use this way, then do it that way. Okay. But I am this far and I need to finish. So if I'm going to try to get a alone, I'm going to clear fractions. In my opinion, clear them both. So I'm going to times by 3a on both sides. And that makes the 3 drop, and it makes the a drop. And I know that's the same as cross multiply. This is the one time where cross multiply would have worked. But I can still call it clear fractions. And now a is canceled here, just to be really clear. That one and that one are gone. Okay, so now it's still got the sine 20 stuck to my a. Well, then I divide both sides by that. So a equals sine 100 times 3. I'm going to put the 3 in front so that people don't think it's sine of 300. You know what I mean? 3 times sine of 100 over sine of 20. And there is your exact answer. If you went and got a calculator answer, it would not be better. It would be rounded. Okay, that's your first law of signs question. We went over it really slowly and carefully. Do you get the whole, I don't like where that little a is. Do you get the whole big A, little a, big B, little b, big C, little c? That make sense to you guys? Don't forget, this is also true that 1/2 the base times the height is how you get a triangle, but there's a new one for that. 1/2 AB sine of C. Next level, finding the area of a triangle. 1/2 times A times B times sine of C. If you use A, B, and C, which you're going to get used to doing, memorize that one. Now, we're going to give it to you on the test, I'll be honest. We're going to give you that one. But on the ACT, they don't give you any formulas. So 1/2 AB sine C could be the thing that like saves your butt on the ACT someday. Okay. Does this look like a good time to use the law of sines? Do we have an angle? Yes. Does that angle have something across from it? Yes. If you didn't have both of those pieces, it's not a good time to use the law of sines. It won't work. You have to have an angle and a side across from it. And in fact, if I've got 2 angles, I've really got 3 angles. You get what I mean? Lucas, what's the third angle then? You work on that while I'm setting up the law of sines. Oh, and it says all the missing info. I'm personally going to start by solving for A.
The third angle is 50 degrees.
All right. You are correct, sir. Okay, so then if I want to solve for A, I'm putting A on top because it'll save me pain later when I'm solving for it. A over sine of A, must be big A then over here, right? Because little a is over here. So then sine of 50 equals, and now we have to use the red ones. We have to have the other 2 pieces. Remember, I gotta have 2 or 3 out of the 4 pieces. Then I need to know this and this, otherwise I can't solve. So this one's gotta be 5.5 over sine of 110. Now we benefit because we set it up in the smart way. Do you get I just have a one-step thing? I multiply by sine of 50 on both sides, and A's alone. Because that'll cancel that. A's alone, 5.5 times sine of 50, all over sine of 110. Okay, so what if the problem comes labeled with Q, R, and F? You are in charge. You can change any letters they give you to A, B, and C. So what if the problem says Q, R, and F? You decide and go, well, I guess I'm going to call Q A, and I'm going to call R B, and I'm going to call, and what's the most important one? C. It's all about C. Because in the law of cosines, you have to have the C angle. I'm telling you, the most important angle, once you pick the most important angle, call it C. It makes your life so much easier. The benefit of experience. Okay, so they have called them A and B just the way they are, so then I know this must be C. And the cm, that just means centimeters, so let's ignore the units for now. So there's A, B, and C. That means this is big A, this is big B, and this is big C. That's the first thing I would do, is get my drawing all labeled out right. Do I have an angle? Yes. If I have 2 angles, I really have 3 angles. Cool, I actually have all the angles. And that means I really don't care which one of them is C. If I have all 3 angles, I'm okay with whatever. Since they came pre-labeled with A, B, and C, we'll just keep it simple. All right, I think this is 75. Can anybody verify that's 75? Okay. All right, then, what do you want to solve for? Doesn't matter. Let's go with A. So then, start with it. Anya, can you tell me what to write next?
Yeah.
A over?
A over sine 40
Yup.
is equal to 200 over sine 75.
I noticed that you picked the one where you have both facts. That was smart. So 200 over sine 75. Did I say it the way you said it?
Yes.
Okay, good. And why did we start with A? So now we can clear it with one fell swoop, one thing. Sam, how do I finish? Sine 40. Cancel, cancel. And there it is. 200 sine 40 over sine 75. That's an exact answer. Better than if you used a calculator. Okay. I feel like you're getting it. Do you feel like you're getting it? All right. Now, I want to just why do we not do the law of cosines here? Or sorry, why do we not do the law of sines here? I don't know the angles. Do I know any angle? I actually do know an angle, don't I? Because it's 3, 4, 5, I know that's a 90. So I could use the law of sines on this problem. Now, would it be your go-to method? Not necessarily, but you could. You got an angle, you got a side across from it. So, I know that you know what this should come out to be. But let's call it B. And I'd like you to just see that this would work. Please use the law of sines and set it up right for this. We're going to call that B. That does force you into which one's A, which one's B, and which one's C. Because in a right triangle, C's got to be the 90. Big C. This one's got to be big B because it's across from little b. And then this must be A. And then solve for little b, please. Have I taught you this enough that you know you have to start with the little b? Okay. Lucas, what goes underneath the little b?
Well, sine of big B.
Sine of big B. Wait a minute. Now I'm doing the law of sines. Do you remember, though, that it felt like we can't do this because we don't have an angle on the side across from it? Those are both mysteries. I can't use those. You know what I mean?
Yeah, we don't have 3 terms.
Yeah, because even if I know this and I know that, I'm not going to be able to solve that. So even though I want little b, as soon as you set up something like this where you got 2 variables here, then it's not going to work. Then I guess we better figure out something else first. Sam?
Can you do the law of cosines?
The law of cosines, you absolutely can use the law of cosines, but we can't we use the law of sines too? All right, well, let's start with the one we know. We know that it's 5 over sine of 90 equals, what can we do then? Yes?
We can figure out, angle A first.
Okay, so would you please tell me how to proceed? Like, what do I put here and what do I put here?
It might help if you wanna do the fractions to flip the first ones, because then you can have the angle on top.
Ooh, you want to do this upside down. All right, so sine of 90, I can do that, over 5.
Is equal to sine of A over 3.
Sine of A over 3. Cool. Do you get, we can solve for A then? Everybody multiply both sides by 3, because you know to clear the fraction there. And A is kind of alone. Do you know how to undo sine? Yes.
Inverse sine.
All right. Inverse sine. Now, we're going to stop going down this road because this is getting to be really a deep problem. But inverse sine looks like this, and you do it on both sides, and that would be a little too tough for where you guys are at right now. But you do on a calculator, if you had a calculator, you do inverse sine of 3 times the sine of 90 over 5. Holy cow, wouldn't it have been a lot easier to just go a squared plus b squared equals c squared? Yeah. That's why we do that when they're right triangles. But the law of sines could have worked. All right. I need to show you which ones you should do for homework. Everybody get to this page. I think you should do one more like this. So we're doing 15, but you can skip 25. This, critical. We're gonna do this over and over. It's kind of like the box problem from that other chapter where we just kept doing the box problem. Gotta do this. And also a really good one. Now, if you're stuck, like, how do I even start this? Do you realize that we have a whole bunch of triangles here? And in fact, we actually have a whole bunch of right triangles here, which is pretty handy. So you'll be able to think of them as different triangles. Like the red one on the outside, that's one triangle. This blue one here, that's a different triangle. And in some of them I have 2 angles, and some of them I have a side, and it's gonna make you think. So thinking hurts sometimes. That's your job. If you can go that far, I'm just gonna look. Oh, these are good. Yeah, we have to do one of these. Number 1. Scribble out 2. Okay. So that is where you'd stop, and that's all I have for you for today. And that's enough. These are just like the other ones.